So that is why I asked. Okay, so let's wait a couple more minutes till the rest of the line. Okay, hi Simeon. Good afternoon. Hope my voice is audible to you, Simeon. So today we are going to begin with a new chapter, that is angles. Okay. Hello, Abraham. So first, I'm going to talk about one important concept from this chapter. Okay, we are going to cover some concepts and then we are going to learn how to draw with compass, how to draw angles with compass. Hi, Abraham. So the concept is about rotation. Okay. Yes. Suppose I'm having a clock. Okay. Now, in a
Why
clock,
is it called rotation?
why is it called rotation? Because we are going to speak about various kinds of rotations. You know what's a rotation? When something moves from a particular point, goes in a round wave, and reaches a particular point. That is rotation. Okay. So suppose I have a clock right here. Here I'm having 12. Here's 6. Okay. 3 and 9. Okay. So now, if I say that my minute hand, okay, my minute hand in a clock, it starts from 12, okay, it starts from 12 and goes all the way to, can you mute yourself, Edric and Abraham, please mute yourselves. It starts from 12 and goes all the way to 12, okay, means it starts from here, takes around till here. So this is known as complete rotation. Okay. This is known as complete rotation. Okay. But what if it starts from 12 to 6? Okay. What if it starts from here 12, goes till 6? Okay.
Semi-rotation.
Yes.
That
Semi-rotation or half rotation. Okay. Half rotation. Then what if it goes from 9 to 12? What if it goes from here 9 to
ma'am,
12? Yes,
ma'am, quarter rotation.
yes. It's known as quarter rotation. Okay. like this way. See, in the clock, okay, in the rotation. Now, what is clockwise rotation and anti-clockwise rotation? If my
Ma'am,
Clockwise
yes,
is from 12 to 3 to 6 to 9 to 12. Anti-clockwise is the opposite of clockwise and goes from 12 to 9 to 6 to 3 to 12.
very good. That is right. Okay, so basically, if I'm going this way, that is 12 to 3 to 6 to 9, it's known as clockwise rotation. Okay, but if I'm going from 12 to 9 to 6 to 3 to 12, like in this way, if I'm going in this way, this is known as anti-clockwise rotation. Okay, clockwise and anti-clockwise rotation we have. All right. I hope till here it's clear. We have various types of rotations. Okay.
Yes, ma'am. Could you just not erase it? I'm still writing it down.
Yes, yes, yes. You guys can write it down.
Ma'am, yeah, ma'am. Thank you.
Yes.
Why are
Ritu?
all the arrows facing the same? Why are all the
Why
arrows?
are all
Why are all the arrows facing to 6?
they are not facing to 6 actually? It is I've drawn it to show clockwise and anti-clockwise. Okay, I've only drawn it half because I'm showing both the things in the same clock diagram. Okay, so in the clockwise you can do the whole arrows you can make in this direction, and anti-clockwise you can make all the arrows in this direction. Okay, all right, so that's now. Okay, so moving forward, we will talk about direction next. Okay, we will talk about directions next. All right. Has everyone written it? Shall I raise it?
Yes, ma'am.
No, ma'am. Can you please explain me what they are doing now?
What we are doing? We are doing chapter 11, Abraham. We are doing chapter 11 and the concept of rotation.
Okay, ma'am. Thank you.
Okay. Have you written it? Okay. Okay. So now we are going to talk about directions. Okay. Now, 1 minute. So this topmost that's on the upper end is north. direction. Okay. Right below, opposite to it is south direction. Okay. To the right is east. And to the left is west. Okay. So these are the directions in general. Okay. Now, there are also directions in between them. Okay. In between them that I'm going to teach you as well. 1 minute. So between north and east, okay, if there is a direction
It's
between
northeast, ma'am.
yes, it's known as northeast. Then between south and east, it's known as southeast. Okay, then between south and west,
Southwest.
very good. Southwest,
And the northwest.
yes, northwest. Okay, so why are we doing directions? Okay, why are we exactly doing directions? Now in this chapter, the 11.1 exercise, you're having some questions that are based on rotation and directions. Okay, so if I ask you that from north to south, what type of rotation is this? From north to south.
Ma'am, half. Clock.
Yes, half rotation. Okay. Or clockwise rotation. Yes, but
Ma'am,
basically it
90
is
degrees.
90 degree. Okay.
No, ma'am. Ma'am,
But,
it's 180 degrees.
Ma'am, yeah, it's 180 degrees, not 90. 90 is quarter, Abraham.
Oh, ma'am, sorry, I got mistaken.
Yeah, so Abraham, we don't measure it in angles, we measure it according to the round it's taking. Okay, that is the rotation it's taking. So it will be half rotation, quarter rotation, full rotation. Okay, like that we measure it. Okay, so if I say that from north to east, what type of rotation it is?
Quarter rotation.
Yes, quarter rotation. Okay. If I say from north to north, what kind of rotation?
It's a no complete rotation.
Yes, it's a complete rotation. Okay, so you're having such kind of questions in your exercises. Okay, so with if you know the directions, okay, you can easily tell that which type of rotation is taking place. Okay, so we have the rotations. Now we will talk about the next thing, that is angles. I hope you guys have written this.
Yes, ma'am.
Okay. Now we are going to talk about the next thing, that is angles. Okay, now from a very basic point of view, okay, from the very basic, I will make two rays. Okay, I'm going to make two rays from one initial point. Okay, I'm going to make two rays from one initial point. Let's make the initial point first. Okay, suppose I have my initial point over here. Okay, and I'm going to make two rays from this point. And one more. Okay, so now what is an angle? An angle is when we are making rays from one initial point. Okay, angle is formed between them. Okay. So suppose my initial point in this diagram is O point. Okay. And let's name the ray. Let's name this ray A.
A.
And let's name this ray B.
B.
Okay, so my angle will form between those two rays. Okay, here.
Ma'am, angle is denoted by a curved line.
Yes, so it is denoted by this sign. Okay, now how do we name the angle? Okay, and what is the initial point called? First, let's see that what is this initial point called? Okay, this O point is known as vertex. Okay, this point is known as vertex. All right, and how will we name this angle? Okay, so
Ma'am,
now, right, but mainly what we do, we also take the name of the rays also. Like we will name it AOP. Okay, so it will be angle
Ma'am.
AO. Yes.
Ma'am, it's ABO because it always go from A to Z. So it's ABO.
No, it's not ABO. It's AOB. Okay, because the what is the angle forming? That point will always come in the center. Okay, no matter what the name is, what the alphabet is, it doesn't matter. But whatever the angle is forming, that point will come in the middle of the name. That point will come in the middle of the name. Or you can name it, angle BOA. But O will always come in the center. Okay, because at O, my angle is formed. So O will be coming at the center. All right. Now, suppose.
Does
Yes,
the
it
point always need to be named O? Does the vertex always
No.
need to be named O?
No.
No, Abraham. No, you can name it with any alphabet, okay? But O is the most common. Okay, commonly
Ma'am.
used alphabet for angle.
Ma'am.
Okay. Yes.
Ma'am, other alphabets like B, E, Y, those are also used, ma'am. Ma'am,
Yes.
those are
Others
the
are also,
common ones.
used. Yes. Okay. Other angles can also be used. That is not an issue. Then we have I'll show you one more diagram. Okay. One more diagram I'm going to show you. Let's name this point E. Okay, and this point C. Okay, and this point, let's name it E. Okay, let's name some more points on the race. If I will put one more point here and name it D, and one more point here and name it B. So now my question from you guys is write all possible names of the angle. Right?
Ma'am, there are so many, ma'am.
Yes, so many possible names. Oh.
You mean combinations, ma'am?
Yes, Anaya.
Ma'am, do we have to write every single one?
Every single one. Yes, you can write every single one. Okay. You can unmute yourself and give me the names. like angle EAB, okay, or DAC,
DAB, DAD.
DAB, okay.
Ma'am, how many do we have to give you?
How many? You can give me all, okay, or some like 2 or 3 you can tell me each one,
Okay, ma'am.
okay. So
Excuse me, ma'am. If two dots are on the same ray, do they have to be written together? They can be written separate as well, like a first and last.
if they're in the same ray, you can write them separately. Like you will use either one of them, okay, either one of them.
AE, BAB, BAD, EAB, BAE, DAC, CAD. Ma'am,
Yes,
ma'am, EAC, CAE, DAB, BAD, EAB, BAE, DAC, CAD.
okay. So you've given me EAC, then
CAE,
CAE,
BAD,
BAD,
EAB,
EAB, okay,
BAE,
DAE, all right,
DAC,
DAC, okay,
CAD.
CAD, all right. So we have 8 names, okay, and that is all. That's all we've got. All right, 8 names will be there of this angle, okay. Now, see, guys, you can see what's one thing that's common in all of them. What's one thing that's common? A is always coming in the middle. Okay. A is always coming in the middle in all of them. So when you are naming the angle, the point at which angle is forming, you will always write that in the middle. Okay. You start from the ray, then to the angle, and then the ray. Okay. Or you start from this side, then the angle, and then the ray. Angle point always comes at the center. Okay. And you can use the angle sign in front of all of them. This is the angle sign. Okay. To denote angle, use this sign before an angle. This sign. Okay. So you can put this sign before all of them. Like this. Okay. So that's how we name them. Okay. That's how we name them. I hope till here everything's clear to you. Okay.
Finish copying, ma'am.
Finish copying. Everyone has written it. Okay. So right now, hope your campus is ready. Hope your campus
I
is
got
ready.
11 names.
11 names, okay? Can you add more to this series? Tell me.
Yeah, I got CAE. Is it there? All right.
CAE is there, yes.
Okay. CAD. Is it there?
CAD, yes, it's there.
I think these are all the possible combinations.
Yeah, ma'am.
Yeah,
These
I think
only.
so.
Ma'am, are these all the possible combinations?
I think so, yes. 8 are the possible combinations, okay? 8 combinations are all the possible combinations, yes.
But ma'am, can it
Is DAE there? DAE.
DAE. DAE is there, Anna, yes.
No, ma'am.
No,
DAE is not there.
DAE. DAE. D.
D.
DAE is not
Not
there.
there. It's not there.
So DAE will not be a combination, okay?
Is
CPS
EDA there?
EDA, EDA will not be a combination as well, because why?
Oh,
Angles
it's
is
only one
always
line.
given. Yeah, it's on the same line. That is, it will not form an angle. Okay, so that is why. Okay, guys. So A should always come.
EDABC.
Ma'am, how are all the
EDABC.
combinations made, ma'am?
How are the combinations made? Okay. So, Abraham, we take the name of the ray. Okay. Take the name of ray. Name of ray. Plus, we take the name of initial point or vertex. Okay. Plus, name of the ray.
So, ma'am, why is there no Z, ma'am?
Why is it not Z means?
Ma'am, there could be more combinations, at least 26, ma'am.
No, Abraham, there won't be 26 combinations. Okay. Because the names of this ray can be either E or it can be D. Or for this ray, it can be the name can be P or the name can be C. And the name of the vertex, this is the vertex. Vertex will be A. Okay. And the name of the vertex always comes in the middle.
Okay, ma'am.
Okay.
Understood.
Yes.
So, only E
Yeah.
and T and B and C. Okay. Thank you, ma'am.
Yes. Okay. Yeah. So now, hope your compass protector, protractor and scale are ready.
Yes, ma'am. Yes, ma'am. I have a protractor, compass, and scale, ma'am.
Okay, so first I'm going to show you a video.
Ma'am, I
Okay,
have
watch
all
it.
the instruments except for the set square.
Set square is not needed, okay?
Thank you,
Set
ma'am.
square is not needed. Yeah. So I'm going to show you one video. Okay, watch it carefully. Then I will be giving instructions to you,
Ma'am.
and you, yes,
Ma'am, this is a half protractor. Ma'am, this is half protractor.
half protractor will work.
Ma'am, why not full circle protractor?
We don't really need a full circle one. Okay, not really right now in this chapter. In your course, we don't really need a full one. Mostly, we don't use a full one. Okay, half one is enough. All right. So, if there is the requirement, people reverse it and then use it for the lower part.
Ma'am, can people use two protractors?
Can people use two protractors at one time? You will only need one protractor.
No, ma'am, can you like join both of them to make them a full circle?
There is a full circle protractor already.
Yes, it is there. Yes, it is there. I saw so many of them.
It's there, yeah. So, but like half circle one also works. Like if you can rotate it to measure. Suppose I'm having one line here. Okay, and there's an angle that is made like this below the line. So what I will do, I will rotate the protractor, put it here, and measure the angle. Okay, this lower angle, I can put the protractor here at the center and measure this lower angle. Okay, so half protractor is
One of
used.
my friends was an engineer. He had a circle protractor, but he only used it for like his engineering stuff. He said otherwise you need only a circle protractor to measure like normal angles.
Only a half protractor is needed to measure the normal angles. Okay, that's right. So I'm going to stop the screen sharing right now. Okay, and I'm going to turn on your
Ma'am,
video.
ma'am, you're using screen share, not whiteboard.
That whiteboard is included in screen sharing. Okay, that's the whiteboard and it's shared through the screen sharing. 1 minute. So the angle that we are going to see right now is of 60 degrees. Okay, we are going to learn how to construct the 60-degree angle using the compass. Okay.
I
So,
already know this one.
okay, that's great, Simran. All right, so watch the video carefully and then I'll instruct you and you guys can draw it. Okay, I'm turning it on. Can you mute yourselves, please, everyone?
Ma'am,
Yes.
ma'am, the 90-degree
It's
one is
super
more
easy.
complicated than the 60-degree one, ma'am.
Yeah, 90 degrees. First, you have to construct 60-degree and 120-degree, and then with those, you will construct 90-degree. Okay, so one by one, we'll learn everything. I'm showing it once
Yeah, because
again.
that
Okay,
will become 180 degrees and then you do it in half.
you do it in half. That's right. Okay, showing it again.
Ma'am, that's called bisecting, ma'am. Do it in half.
Ma'am, I have a question.
Yes, Abraham. Just 1 second. Now you can ask me after watching it. Okay. Yes, Abraham. You can ask me now. You had a question.
If you're going to a 60 degrees angle,
Yes.
ma'am, how will we draw it? Like, can we use a protractor?
Do we use the protractor? No, Abraham, we don't use the protractor. Okay. Let's draw it now together. Just give me 1 minute. Just 1 minute. So I am going to give you instructions. Okay. I'm going to give you guys instructions one by one. And then you guys are going to draw the angles. Okay. So we are going to draw first angle of 60 degree. Okay. You guys just have to follow the steps. All right. Angle of 60 degree. Okay. Now, step one, take your scale. Okay, all of y'all, take your ruler and your pencil. Done. Now,
Yes.
you guys don't have to write this right now. Okay, you guys just have to do what I'm saying. Okay, draw a line segment. Line segment AB of 8 centimeter. Draw a line segment AB of 8 centimeter.
I'm done.
Done. When you guys are done, you can just tell me done, ma'am.
I'm done, ma'am.
Done. Okay. Now, this is A and B. Have you named it like this?
Yes.
Yes.
Very good. Now put your compass on point A. Okay. With
Ma'am,
A
done, ma'am.
as set. Done. Now, your center will be A. Open up the compass. Okay. Hope it has pencil in it. Okay. Open it up and draw from the compass on point A. Okay. And pencil here. Pencil here. And put a semicircle cutting the line segment AB. Okay. Cutting the line segment AB.
Ma'am,
Alright.
how long do you have to draw the line
It
segment?
can be any size,
Semicircle.
like the
Any
circle.
size. Any size. Okay. Circle can be any size. How long? Just cut it through your line segment AB a little bit further.
Yes, ma'am. Done, ma'am.
Done. Now name this point O. Name this point O.
Okay. Oh,
Okay. Done.
Yes, ma'am. Done, ma'am.
Yes. Now don't change the
wait, ma'am,
radius
I'm not
of
done yet.
not done yet. No problem. See, don't change the radius of the compass. Okay. Like this is your compass, suppose. How much you have opened it, keep it that much only. Keep it that much only. Okay. Don't change its radius. Don't shift it. Okay. Now put your compass on point O. Put the compass on point O. Okay. Remember the radius of the compass should be the same. Okay. Don't change that thing. All right. It should be the same. Okay. Now put your compass on O. Okay. And your pencil here and make a cut. Okay. On the semicircle. Make a cut on the semicircle with your compass on O point and pencil on the semicircle. Okay. Cut an arc. This cut is known as arc. Okay. ARC. It's called an
Ma'am,
arc.
ARC or ARK?
ARC.
Yes.
Okay. So arc is cut on the semicircle. Now, done till here, guys?
I'm done.
Okay.
Done, ma'am.
Okay. Now, put your scale on the point A and take it to the points. Cut the arc on the semicircle and draw a line like this. from point A to the point where you cut the arc on the semicircle, draw a line. Yes, Andrew, that's right. Okay, here you put an arrow actually. Here, at this point, you put an arrow. Yes, Sanjay. Show me. Yes. Okay, that's right, Sanya. Abraham, can you remove the background? I can see it. Yes, now I can see. Okay, that's right. Good. Yes, and yours too. Can you show me? Now, yes. Move it a little to the side. Okay, yes. Good. That's right. Now, put your protractor, okay, on it and measure. Put your protractor on point A, okay, the center of the protractor, center of it on A point, okay, the
Now it's
center,
exactly 60. It's exactly 60 day. 60
very
a.m.
good, good,
Mine is point A,
Mine is also 60.
okay, good, Sanya. Yes, Abraham, what's
but
yours?
mine is a little lesser than 60.
Little lesser than 60, okay, no issues, for the first time it's good. See now, Abraham,
And it's
what
kind of
happened
on
was,
60. Kind of on 60.
kind of 60.
Same here, ma'am.
Okay, Edric, yours is exact 60 or kind of 60?
Ma'am, between the 60 mark, ma'am, between the 60 mark, I don't know where, ma'am.
Between the 60 mark. Okay, now see guys, what happens? Why did you get a little bit up or down 60? Because
Because
your,
probably the point was off.
yes, okay, or the width of this compass might have moved. Okay, so this should not change. Not change.
My compass changed a little bit.
The compass changed a little bit. That is why it was little bit up or down 60. Okay, so
Ma'am,
this should not change.
Abraham could have put his compass point on A and the pencil on O, and then he could have gotten the exact measurement back.
Yes, he could have gotten the exact. Okay, so if by chance your compass moves, Abraham, you
And
can put it.
And I did that.
You did that. Okay.
But
No
still
issues.
it
It's good.
happens.
It's okay. No problem. You can try it out again at home. Okay. You can try it out again at home. No issues. You'll get it. Okay. But make sure that the radius of the compass doesn't change. Whenever you're cutting arcs, okay, it should not change. All right. So more angles. We've stopped here right now. And more we will do tomorrow. Okay, we learn more angles, we learn 90 degree, we learn 120-degree, and all that also. Okay, so that's all for today. That's all for today's class. See you, Edric, tomorrow.
Bye, ma'am.
Okay, bye. Bye. All right, so 5 minutes break, guys, and then we'll meet up for the science class. Hello, okay, by the way, we are going to start with the science class. Please turn on your videos. So we started with the chapter of nutrition in living organisms, and we had talked about various kinds of organisms, okay, based on their nutrition, based on the food they eat. Okay, and today, following that, we are going to talk about nutrition in amoeba. Okay, so an amoeba is a unicellular organism. Okay, and let's talk about its nutrition. Okay, how nutrition in amoeba takes place. So, amoeba is a single cell being, okay, which means unicellular, which is found in water bodies. Amoeba can change its shape continuously. Joint artificial legs are found in amoeba, which have the shape of finger. These give motion to the amoeba and helps them in collecting food. Amoeba is a single cell which has one cell membrane, central, and other food vessels. Amoeba takes small food by joint. These get stuck to its stomach. These secretes digestive juice. This digestive juice changes the food to smaller and simpler food items. Also, this juice helps in the absorption of food items in the cell. Okay, so can you see this portion? Okay, these are basically the artificial legs, okay, of the amoeba, which helps them to move, okay, which helps them to move. And also the food particle gets stuck to it. Can you see this black thing? This is the food, okay, which gets stuck to it, and then it moves here, okay, and here it secretes digestive juices, okay, which helps in its digestion, okay. It changes or breaks down the food into smaller particles and then helps in their absorption, okay, into the cell, helps its absorption into the cell of amoeba. This substance gives energy to amoeba to do many works. The non-digestive food is excreted. The basic structure of digestive system is same in all the living beings. This helps in simplifying the food items and release energy. Okay, now we are going to talk about the digestive system in living organisms. Okay, digestive system in living organisms. So 11.2 you can try out. Okay, Abraham and Simeon, please turn on your cameras. Please turn on your cameras. Yes, now human digestion. All living beings, whether single cell or multicellular, have the digestion of food as a common factor. The digestion of food is divided into 5 categories. Okay, now the digestion process is divided into these 5 steps. Okay, that is intake. Okay, means when we eat the food, then digestion that takes place. Okay, means the food is digested in our systems, then absorption of the nutrition, okay, from that, then the utility, and then at the end it's excreted. Okay, the in the utility portion, the important components from the food is taken in by the
Can you go a
body.
bit slower? I want to copy.
Yes, Simeon, surely. Yeah, so absorption and utility means it absorbs, it takes in all the important components, okay, from the food, okay, and then the rest, which is not important, okay, which is the waste material, comes out of the excretory system, okay, comes out of the excretory system. It's excreted, All right. So, now the food eaten or taken by human mouth is passed through a continuous pipe. This pipe starts from mouth and ends on anal. Therefore, there are the following areas of this pipe, which are, okay, so I'm moving it up. Yes, now there is a pipe. Okay. So from mouth, when we take the food in, goes to the food pipe, okay, which takes it to the stomach. From stomach, it's taken to small intestine and then to the big intestine joined with it, and then to the anal, okay, means that for excretion. This is the last process, okay. And here is the intake. Okay. Then here is somewhere here is the digestion. Okay. And then absorption and utility.
How do you think an atoms also have some unique characteristics? So how do you give characteristics? Human characteristics for the ground floor is movement.
Utility. Okay.
Characteristics of the
Mute yourself, Abraham.
It says big intestine joined with, and then it just is blank. What does that?
I think it wants to say that big intestine joined with anal. Okay, because after the big intestine process, it directly the excretion happens, because here we have absorption is done. After the absorption, what's left is after the absorption, what's left is the waste. Okay, what's left is the waste, which is excreted out. Okay, so this is basically the digestion process. All these
Okay.
parts together form, yes, the digestive system of humans. As food goes inside, various processes start in the sequential form of digestion. Let's learn what happened to the food in various parts of the human digestive system. Okay, so let's talk about it. Mouth intake. Mouth is used for taking food inside in humans. The process of taking food inside human body is known as intake. Okay, when we eat the food and it goes inside us, okay, through the mouth, it is known as intake of food. Okay, that is known as intake of food. So this is basically all the system. Okay, from the mouth, this is the mouth. Okay, where the intake takes place. Intake starts from the mouth. Okay, and here is the anal. Okay, where the excretion takes place. Okay, we have the large intestine. Okay, and the small intestine. Okay, stomach. Okay, the food pipe. All right, then all of the systems we're having. Okay, we're having the pancreas. Okay, and in the mouth also. This is the tongue it has mentioned. I'm going to put the English diagram in the group, okay, so that you can clearly understand it. All right. Then we will talk about teeth. Now, when we take in food, okay, it is in a bigger form. Okay, it is in a like solid form, basically. Okay. So what does the teeth do? It grinds the food to make it smaller. Okay. to make it easier to digest. If we directly eat that solid piece of that solid bite that we take in and swallow, it will get stuck in the food pipe. Okay, it will get stuck here in the food pipe. It will be hard to digest it. But the teeth, they grind it together, okay, and make it in a more less solid form so that it goes inside the food pipe easily and then it is easy to digest it. Okay, so now the teeth also, they have different types of teeth. Okay, different types of teeth we have in our mouths. There are total number of 32 teeth inside the mouth. Okay, the mechanical process of chewing makes small pieces of food. So main thing is to make the food into small pieces. Now I'm going to show you one image, okay, in which you can clearly see the back teeth, okay, the wide ones are known as molar, okay, the back ones. Then just in front of them, which are less broader, are known as premolars. Okay, premolars. All right. Then the ones that are right in front, okay, the ones that are right in front are known as incisors. Okay, incisors. And after the incisors, the pair that we have here and here are canine. Okay, so first the exactly front teeth are incisors. Then on both the sides, the next pairs are canine. Then after that we have premolar, and at the back, right at the back we have molar. Okay, right at the back we have the broad ones are molars. Okay, how do they look like? How do they look like? This is how they look like. Okay, this is how they look like. Incisors, canine, premolar, and molar. Okay, this is how they look like. Now, what do they do exactly? What do each of them do? Now, the front teeth, okay, that is the canine, okay, are used to cut the food, okay, or tear into the food, to cut the food, okay. Then incisors too, okay, to tear apart the food. Canines basically to cut the food, and incisors to tear them apart because these are very sharp. Okay, these are sharp ones. Then we have premolars. They work for chewing and grinding the food. Okay, to chew and grind the food. Okay, and then molars. Okay, this is also to chew and grind the food. Have you ever seen when we are eating something, first we cut it through the front teeth, right? When we're taking a bite of a cookie or a biscuit or something, we use the front teeth to take a bite, right? We don't insert the whole big cookie behind the mouth and take the bite from molar, right? We don't do that. We take the bite through the front teeth first. We take a small bite from the front ones. Those are to cut the food, for biting into the food. And then when we have broken it into smaller pieces, then it goes to the back of the mouth and you chew. Okay, chewing is done from the back. We don't chew from the front teeth, right? We don't put the food, solid food at the front and do like this. We don't do like this. We take it at the back and we chew. Okay, so that is mainly the function of all the teeth. Okay, then in our mouths, we also have saliva glands. Okay, saliva glands. Now, when we eat something, okay, or when we crave something, or when we eat something we really like, okay, the glands secrete saliva. What it helps in, it makes the food soft. Okay, helps the food to change to sugar, which makes the food soft. Okay, this turns the food soft. The saliva that the salivary glands excrete, okay, it makes the food soft. Now then we have tongue. Tongue is made up of muscle. Okay. Hope you all know that tongue is made up of muscle. Now it is linked towards the back side of the mouth. The other part of the tongue is free. The front portion can move in any direction. Tongue does a lot of functions. Tongue is mostly used to speak. Tongue is also, it also helps in mixing saliva in food. These are the functions of the tongue. Okay, helps us to speak, helps us to mix saliva in the food. Also helps in pushing the food to the pipe. Okay, which softens by mixing of saliva. Now, then there is another function with which you are familiar. Tongue also helps in tasting, for us to taste different types of food. Okay, to tell us the taste of different types of food. Okay, tongue has taste cells on various parts to identify the taste. Now, if you see this diagram, it tells of the taste cells. Okay, so here at the back of it is bitter. Okay, then on the sides, the purple thing is sour. Okay, here it's salty. Okay, and here at the edge of it is towards the very end, like it's sweet. Okay, so these are all the cells. Okay, taste buds, it's called. Okay, it's also called taste buds that are present on the tongue: sweet, salty, sour, and bitter.
Ma'am, question, ma'am. What about the middle part of the tongue?
Middle part of the tongue, it's like present on like both the sides, and I think the middle too.
Ma'am, what taste is in the middle?
What taste is in the middle? I think this part is salty, okay? All of this is salty, then this thing is sour, okay? The middle too, middle as well, and this is bitter, okay? This
Ma'am, what
includes.
about spicy?
What about spicy? I don't know. I think it's present on the whole tongue. Just kidding. That's not exactly true because when we eat spicy, you can feel it all inside our mouth. So I think spicy is in the middle, Abraham. Just kidding. I'll see about the spicy, okay? Yeah. So now this is an activity. You can read it out, okay? Then the next is food pipe. Food is taken by mouth, is transferred to food pipe. This food with the help of this food with the food pipe goes to chest. The contraction and expansion of food pipe walls helps the food to reach slowly. Okay, food comes from here, from the mouth. Okay, from the intake is done to the stomach, it enters. Okay, and the food pipe, the contraction and expansion happens, which pushes the food forward to reach the stomach. Okay, then we have the stomach. Stomach is a thick walled polythene shaped organ. This is flat and U-shaped. This is widest part of the food pipe. Can you mute yourself, please, Abraham?
I'm sure this might be fine. Optimism is a type of positive thinking that also involves believing that you are responsible for your own happiness and that bad things that happen are.
Yeah, please mute yourself. Yeah. So this is the widest part of the food pipe. It connects food pipe on one end and connects the small intestine on the other end. Okay. Here, okay, this is stomach. Okay. And here it connects the food pipe on one end. Okay. And then small intestine, it connects here. Small intestine, it connects on the other end. Okay. When food reaches stomach, it secretes a type of digestive juice from internal walls, which include mucus and hydrochloric acid. Okay. So the walls of the stomach, it secretes these digestive juices that are mucus and hydrochloric acid. Mucus provides security to the internal surface of the stomach. Acid destroys those bacteria which reaches stomach with food. It also makes the food acidic. Acidic food helps digestive juices in doing their activity. Digestive juice breaks breaks the protein present in the food into simpler substances. This is the main function of the digestive juices. Okay. It breaks the protein into simpler substances. Then we have small intestine. Stomach sends food to small intestine. Small intestine is about 7.5 meters in length, narrow, and has a spiral pipe. Okay, has a spiral pipe. The walls of small intestine secretes digestive juices. Now, the walls of small intestine also is secreting digestive juices. They help in the digestion of protein, carbohydrate, maltose, sucrose, and fat. Okay, means glucose, carbohydrates, protein, and fat. Okay, digestive juices from small intestine helps in the digestion of all these. Liver is a gland of deep red color. Okay, this is the liver. This is the biggest gland in the human body. It is found in upper part of the stomach and is on the left side of the stomach. Okay, can you see this on the left side? Like the upper part of the stomach and on the left side of it. This makes genic juices which are stored in one part of the liver. This part is known as gallbladder. Can you see this green thing? This green thing? This is known as gallbladder. Okay. During digestion process, genic juices is sent from bladder to small intestine. Genic juice plays an important role in digestion of fat. Okay. Pancreas is also a big gland of light yellow color. This is pancreas. Okay, this yellow thing is pancreas. Okay. This is situated just below stomach. Pancreatic juice does affect carbohydrate and protein. Due to this, protein gets transformed into simple form. Food is digested partially by means of these digestive juices. Okay. Now, till here, the food is digested partially. Okay, from the with the help of the digestive juices from stomach. Okay, from the gallbladder, from the pancreas. Okay, now the rest of the digestion takes place in the upper part of the small intestine. When food reaches the lower part of small intestine, it gets digested fully. Okay, it gets digested fully. Carbohydrate is changed to simple sugar like glucose. Fat is changed to fat acid and cholesterol. Protein gets changed to amino acid. Okay, this is the changes that takes place when the digestion has taken place. Okay. Then we have absorption in small intestine. Digested food is absorbed by blood vessels on the walls of, I think it's in the walls of small intestine. This process is known as absorption. Okay. This digested food is like absorbed by the blood vessels. Now we are on the absorption step. Okay. Till now we talked about intake. Okay. Then after intake, we talked about, what did we talk about? Digestion. Okay. Talked about how intake happens, then digestion, how it happens. Digestion has happened. Now we are on absorption part. Okay, now where does this absorption is taking place? Okay, where has this absorption is taking place? In the small intestine. This process is known as absorption. Small intestine has the walls, has the structures of curved fingers in the internal walls. These are known as tunnel. These blood vessels enlarge the base area for the absorption of digested food. Okay. Absorbed food from the mule goes to vessels. Blood vessels take the absorbed elements to heart to by the way of liver. From there, these food materials are sent to various parts of human body. These are used to make complex elements. This process is known as assimilation. Okay. This process is known as assimilation. What is assimilation? Again. See, once the digestion has taken place, then the absorption process starts in the walls of um, the small intestine. Okay. So, in the walls of the small intestine, small finger-like structures are there. Okay, which absorb the important nutrients. Okay. Now, absorbed food from the frenule goes to the vessels, and blood vessels take this absorbed food, okay, or the nutrients to the heart, and from the heart it is supplied to all the parts of the body, okay, to the other parts of the body, okay. Then those are used to make other complex elements. So this whole process is known as assimilation. Okay, this whole process which is taking place is known as
Can you go a bit slower?
yes, Samir, yes. In this process, glucose is broken in the internal part of cell with the help of oxygen. This activity forms carbon dioxide in water and also releases energy. Okay, the breakdown of glucose takes place. Okay, breakdown of glucose is taking place. Okay, so in the presence of, with the help of oxygen. Okay, now when this happens, because glucose is what? It's a complex substance. Okay, glucose is a complex substance. So its breakdown takes place with the help of oxygen in water, and it releases CO2 and energy. Okay, energy is also released in the process of this breakdown. All right, then we are having big intestine. Okay.
So that is done in the liver,
That is done in the liver.
like the glucose plus the oxygen, the assimilation.
The assimilation process. I'll see Simeon. Okay, I think the liver helps with it. Okay, liver helps with it. I think this is done in the small intestine. Okay, because we are talking about small intestine, the absorption and the assimilation process of the small intestine we are talking about. So I think this breakdown is taking place in the small intestine. Okay. Then the last one is big intestine. That part of food which does not get digested or absorbed goes to the big intestine. Okay, so the absorption process ends to the small intestine. Now, what happens with the food which is not absorbed or not digested? What do we do with it? So that food which is not digested, neither absorbed, goes to the large intestine. Okay, that food enters the big intestine. It is smaller but wider in comparison to small intestine. Okay, it is about 1.5 meter length. The main work of big intestine is the absorption of water and some salts. Okay, the absorption of water and some salts. Okay, at the end, and then the undigested part of food is sent to the anal. This gets out of human body by anal. This is known as excretion. Okay, like I said, it's excreted out of our body in the form of urine or feces. Okay.
I just want to copy it.
Okay, so then you can copy. Alright, so then it ends with the excretion process. So this is the digestion process and it has ended. And the chapter is also ended with the digestion process. Okay. So it was a short chapter. Yes, Abraham.
Ma'am, the intestine, ma'am, 1.5 meters is how much?
1.5 meters is how much? How do I tell you? Mm,
Ma'am, 1 meter is around 3 feet.
yes, that's right. Okay. So it's
Yeah.
3 feet and half more, 1.5 more.
Like around that much. It's 3 feet point something something.
I am grateful to God that we're doing homeschooling. That we're not.
Okay, yes, probably like this much. Spread your hand, both the hands, and
Because I
probably that much is and 1.5
have to be done by the
is like smaller.
fusion was that ये बंदे का तो अभी तक एक हुआ नहीं है पर
Big intestine is like smaller in length than the small intestine
best to give it in 2026.
Why is it called big in intestine then?
because it's more wider.
It's
I
fatter.
think. Yeah, it's wide. It's wider than the small intestine. So that is why. Okay, so we just finished with the chapter. Okay, in text questions 11.3, you can try out. And please finish
This is
up
the
the,
homework.
yes, end of chapter questions. Okay, you can find out the answers to them. Okay, end of chapter questions, you can find out the answers. What diagram is important? What diagrams are important? Liver and bladder is less important, but this diagram is very important. Okay, I'll be sharing the English diagram for this in the group. Okay, this is very important.
This
It's
has to
asked,
be learned.
this has to be learned, yes. Okay, and then this diagram also is important. Where's the teeth diagram? 1 minute. Yeah, this diagram also. Okay, this also has to be learned when you are explaining the teeth. Okay, when there's a question on the types of teeth present in our mouth, that time this diagram you can draw with the explanation. Okay, so this is also an important diagram. Both of them are important. In fact, the amoeba diagram also. Okay, amoeba diagram also. You guys can. Amoeba diagram is like literally in every chapter. Amoeba diagram.
We've drawn it many times, so I know how to draw them.
Yeah, that's right. Okay, and this is the structure of pores. Okay, pores. This also is important diagram. The open. This is the closed one, and this is the opened pores. Okay. So if you are explaining photosynthesis process, that time you can use this diagram. Okay, when you're explaining the photosynthesis process. Okay, now some points I wanted to discuss about the test. Okay, I haven't checked the science test yet. Okay, but in general, like keeping in mind the all the previous science tests that I've taken. See guys, when there are long questions, okay, when there are long questions are given. What are long questions? Questions of 5 marks. Okay, 5 marks or even 4 marks. 4 marks are medium and 6 marks. Sometimes I give 6 marks questions. So those are very lengthy questions and I'm expecting lengthy answers. Okay, I'm expecting long answers, elaborated answers. So when you are writing 5 marks or 6 marks questions, please give me 5 points to 6 points. Okay, and please answer in points. Okay, no paragraphs. Please answer in points. All right. So suppose if it's
Or
a 5 mark question. Yes, Samir. For diagram,
I heard
what
it
do you
as
want?
diagrams. No, I heard it as you said for paragraphs, write it in points.
Yes, yes. The answers, please try to write the answers in points. Okay, make it in points. 5 mark question means 5 points, not one line points. Okay, minimum 2 line point each. Okay, minimum 2 line point each. All right. So that will be around 10 to 12 lines for the lengthy questions. Okay. And when I'm asking the difference between, when I'm asking the difference, okay, difference between this and this, okay, please try to answer in, make a colon, okay, make a colon like this. Let me explain here, okay. Make a colon like this. Suppose I've given the difference between arteries and veins. So make it like this, write arteries and veins. Okay, then for point 1, write what this artery means, write what this vein means. Then 2, leave one line, 2. Okay, then write what is like the walls of arteries thin or thick, walls of vein thin or thick. Third point, if they carry blood towards the heart or if they carry blood away from the heart. Okay, like this. So if there is a difference of 3 marks, so 3 points I'll be requiring. Okay, and see, colon thing is only necessary when you are writing difference. Okay, because you are comparing two things. Right, when we are writing the difference between, we are comparing two things. That is why it's essential for us to write in columns. Okay, if 3 points, then 3 marks. 3 marks, then 3 points. 2 marks, then 2 points. Like that, you can answer it. Okay, so for the next test, please keep this in mind while answering the questions. Okay, so that's all for the class today, and I'll see you guys tomorrow.
Thank you, ma'am. Bye, ma'am.
Ma'am, just
Okay,
one thing.
Bye.
bye, bye. Yes,
Yes, I
Abraham.
have to ask you one question, ma'am. Sometimes, ma'am, sometimes there's these 1 marker questions. So there's just 2 to 3 marker questions, ma'am, where we can't write, like when we draw the diagrams, ma'am, there is like it's not specifying how many it wants, how many questions how many points it wants, ma'am. Then what should we do there?
If it is a 2 mark question, then minimum, like you can write 2 points minimum. Okay, minimum 2 points, 2 lines each point. Okay,
Okay, ma'am.
so points you can write. Okay, or if the answer you think is it cannot be put into points, so 3 to 4 lines you can write. Okay,
Ma'am,
but try to make put it a point. Yes, Abraham.
another question is that, ma'am, in this, when you had given this answers, ma'am, there was these points, ones that answer in one word. So in that, which do we have to write it in the point or only that one word?
Sorry, which one, Abraham? I didn't
That-
got the question.
Ma'am, it said that answer in one word.
One word, yes. So when I say one word, then it's okay if you answer in one word. I will not cut marks.
Okay, ma'am.
Okay.
Right.
Okay. See you guys tomorrow. Bye.
Bye, ma'am.
Bye, ma'am.
Bye.